In the previous video, we introduced the dataset that we will be using for multi-label classification. In this video, we will get comfortable with this dataset by using Python to visualize the images and look deeper into the class labels and their distribution. Let's get started. Hello everyone and welcome to ML-Done. So let's get started with getting comfortable with this particular dataset. Now I've created a Jupyter Notebook here next to my dataset, right? So this is my Jupyter Notebook here. If you open it, first and foremost, you've got the link to the dataset here. The name of the classes are here. Number one thing, we have to import some packages. So Numpy, obviously for numeric reasons, you need Numpy all the time. And you need Pandas because you want to read the CSV files, the class labels, so you definitely need Pandas. It would make your life much easier. From Matplotlib.pyplot, you will need PyPlot module, and I'm going to import it as plt because that's how you can actually visualize these images. tqdm helps you sort of keep track of the progress whenever you have some iteration, some sort of a loop, for loop, for example, or while loop, to sort of give you some sort of a progress bar so you know how long you need to be waiting for. From PIL, I'm importing image, so this is what I'm going to be using to actually import those JPEG files in my images dataset class. And of course, import OS is always a good idea to have it, especially whenever you want to work with paths, read files from different paths, and save files to a particular path. We're going to be reading the dataset, or let's say the actual ground truth first. So we got a bunch of CSV files here. As a reminder, the Jupyter Notebook is here and the dataset is here. So we need to go into the dataset folder, we need to go to a multi-label modified folder, and we need to go and read this labels.csv file, right? So I have to define this path and tell Python where it could actually find this particular CSV file. So let's call this the path, and I'm just going to put this as a string. So dot means this exact directory, right? And we go into these folders and we grab the CSV file. And then you can use Pandas that we've imported as PD to read the CSV file. And it's pretty simple. So df, that's the short for data frame, because Pandas would read CSV file and would create a data frame, some sort of a unit of measure in the world of Pandas. And then you can go pd. Okay, good. Read CSV. By the way, I clicked on tab. If you want to know how I made that list appear, I just clicked on the key tab on my keyboard, and that's how the list appeared. So I want to read a CSV file, right? And it needs the path, and I'm going to pass the path. And if we just run this, if it works, okay, it's working. Now you might want to actually see what the result is. You can actually look at maybe, for example, the first 20 rows of this data frame. There we go. So this is my data frame. Image name, the classes, motorcycle, track, these are the actual classes. You've got the 0 and 1s here for the vectors of multi-label classes, and you have the name of the files here. And you actually have the actual name of the class here. For example, if you have bus here, you know that the flag for bus is 1 and everything else is 0. So for example, if you have tabla and harmonium here as the two classes that image 11 belongs to, if you look at this vector, you see that the flags for harmonium and tabla are 1 and everything else is 0, right? So that's why this is a very nice dataset for multi-label classification. I'm just gonna maybe rename this sort of, this long list of names here, because that's just difficult to work with, right? So one way to actually do this is to first grab the list of all the columns in my Pandas data frame. And Pandas has a very nice sort of method here that could help us do that. So df.columns would give the list of columns, but it's not actually a list, right? So if I just run this, it's not an actual list. You can actually convert it to an actual Python list, and there it is, that's a list, right? And you can just put it in a new variable, column names, right? So again, just to confirm, yes, we have that. Okay, now we're gonna use this column names to rename only the second column. right? So if you look at the column names, it's actually the second index in this list, or the actual index for it is 1, right? Because in Python we start with 0. So 0, index 1, index 2, and so on and so forth. So you just want to change the actual column name in index 1. So to do that, again, Pandas has a very nice functionality called rename, right? And this is where, for the columns, so it expects columns, the columns that you're interested in. And what I'm going to do is, I'm just going to change the column that lives in the second index, right? So I'm just going to go column names and column names 1, right? What I'm going to do is, I'm just going to replace that with a new value. Let's call it, this is the actual new value that I want to put back in my data frame. But if you want this to be an in-place operation, so that it would affect df immediately, right there and then, you can put in place and sort of flag it as true. And if you do that, and you look at df, right, so your df has changed. So this is the particular column that you've changed, right? Next thing is you would like to extract the labels from the data frame. So remember, if you want to use a neural network to actually create a multi-label classifier, for example, you would need these vectors separately. You want to have that, right? You want to have them separately out of this data frame. So you need to extract those labels. So you need to iterate through this data frame, and for each row, you need to grab the values that live in these particular columns. And you're going to append those into a list. And how can you actually iterate through a data frame, and how can you actually say that for each row you want to cut basically that row from here all the way to the right? How can you do that? So let's see. First and foremost, I'm just going to create a sort of variable labels. So this is where we're going to be putting these 0 and 1s into, and then I'm going to iterate through the data frame. So when you iterate through a data frame, you can actually iterate through the iter rows method of df. So you're actually going to be going through the indices and the rows in. So you have to call df.iter rows. So df.iter rows give you access to the actual rows, and it passes the index and the actual row information in that particular row, and you'll be iterating through each one of the rows. For every iteration, row becomes an entire row, right, in the data frame. So I want to just grab in that particular row. So wherever you want access to a row, you can actually use a method called ilock, because I'm going to be using an index here. Now, if I want to say that, so particularly from this particular index, I want everything else to the right. So if I put -1, it means from the end of this row, which is this part, it means only grab this value. -2 means the last 2. -3 means last 3. -10 means last 10 columns, the values, grab them, right? So that is how you can just say from -10 all the way to the end. So double dot is all the way to the end. So this is where the cutting happens. What you're grabbing here is not an actual list. It's still a data frame object. So you can actually convert this into a list, because we love lists. And you can append this entire thing into your labels. So you can just say labels.append and put the entire thing into it, right? And that's it. So let's iterate through it. Okay, it worked. So just to be on the safe side, let me look at, for example, index 5 to 15. Yeah, so exactly. So you've got each one of the rows stored in the labels list. So if you look at here, this is going to be, I think, the first row, literally. Yes, literally the first row. The second one is going to be the second row, and so on and so forth. And I'm always in the habit of converting everything to NumPy array. So I always create a list of lists and then turn them into a NumPy array. It's just a habit, and it's always worked for me. So I suggest that you do the same. NP array, labels, and then you can actually look at the shape of this NumPy array, right? Exactly, so the exact number of images that you have, and you have 10 columns here. Perfect. Now let's actually read the images. I'm just gonna look into all of the image names here, into the in the actual column named image name. I'm gonna grab each one of these images, right? Each one of these names, and I'm gonna use this to define a path into each and every one of the images in my data set, right? So using the name of the image, I'm going to create a path to that particular file, and I'm going to read that particular image, and then the second one, third one, fourth one, right? So I'm going to use those names. First, we're going to get the name from the data frame and put them in a list, right? So again, it's very, very simple. Like again, data frame makes it really simple. It says that from this data frame, look into the column image name, convert it into a list. And let me look at what is inside that variable. All right, so you got all the images here. These are, remember, these are strings, and these are just the names of the images. Okay, maybe just put 0 to 5, just to make it. Yeah, good. Now we're gonna actually read these images, right? Now let me create another variable here, images. Again, an empty list, the exact same thing that we did with labels. And I'm just going to create a root path here. And the root path is a string that points to the images folder, right? That means this directory is exactly where the Jupyter Notebook is, right? That means this directory, go into dataset, go into multi-label modified, and go into images. So that's what all of these images share. But from there on, I'm gonna append that root with the name of each one of these images that I've extracted, and then read the image that the entire path points to. I'm just gonna create a loop. Okay, good. So we're iterating through image names, right? And at each iteration, image name becomes one of these strings, right? And if you want to be able to see a progress bar when the iteration happens, I would suggest that you use the tqdm package. Just literally wrap the object that you want to iterate over into the tqdm, and you'll see what I mean. It looks very nice, actually. Now, I can define an image path, right? So my image path is going to be equal to this root, right, concatenated with the name of the first image, and then this root concatenated by the name of the second image, and so on and so forth. So the way you can concatenate these two together and still create a legitimate path for the operating system to be able to access that particular file, you're going to use the OS package that we have imported. And from there, you can call the path method and then join. This is where you can join two different strings and create an actual legitimate path. And this is where you use the root that you have and then the image name, right? I mean, before I continue, let me just show you what these image paths look like, just so you'll be absolutely comfortable. There is a problem. Okay. Root. Okay, you see? Each path points to a particular image. When I have that path, I just want to use that path to read the JPEG image that lives in this path. And that is where the image package comes into play. I can go Image.open, and then you pass the image path to it, right? And remember, when you read this, when you open this, it becomes the actual image, the pixel values, literally. So you can put this in a variable called image. So image now is the actual values of the pixels. You can create this, turn this into a Numpy array. It's always a good practice. I always do this. And finally, you can append this into your list images. So this is where the first image is opened and put into the images list. And if the iteration keeps happening, you will have collected all of the images, right? Living in all of these paths. So at the very end, you will also, because now images is a list of NumPy arrays, you can turn this into a NumPy array of NumPy arrays. Again, you can do this very easily. So let me just run this. It might take a while, by the way. And you'll see what I mean by a progress bar because you've used tqdm. We're done here, so let me look at images and see what the dimensionality. That shape, because it's a Numpy array. Okay, good. 7,943. Now, what I'm going to do, I'm just going to visualize this entire thing, right? Like all of these images, but I mean, maybe some part of them. Again, so you got your images, right? So you can literally go for image, or let's just call it img, and then I can go iterate over images, right? And here, you can literally go plt, so this is your Matplotlib, plt.imshow, and then you literally pass your image to it, right? And then you just call plt.show. And then I'm just gonna stop maybe after 10 images. So if you want to also have indices, some sort of a counter that keeps track of the number of images that have been shown, I can actually put idx here as the indices of the images, and I can put enumerate here so that every time an object is retrieved from images, you would have both the index of that object as well as the actual content of that object. So here I can, the index idx just becomes 0, 1, 2, 3, so on and so forth. So I can here just say if idx, for example, is bigger than 10, I just want to break out of this because I just want to visualize this, right? Okay, good. So you have the objects, the actual images here as well. Now, one other thing that is left to do is to get some statistics of the class labels, right? For example, how many tablas do we have? How many harmoniums do we have? Again, in order to do that, first of all, let me look at the labels that I have created just as a reminder. The shape is this, right? First, let me count the number of labels across all of the labels Numpy array. So if you consider this as a two-dimensional Numpy array, I'm just going to count the number of ones across each one of the columns, across each one of the 10 columns. And the way to do that, again, you would use Numpy, right? And you would count across the axis 0. So across, for each row, you would sort of count vertically, right? So that's why the total number of class labels at the end will be retrieved like this. And let me just put this in a new variable. Let's call it once count per column, the number of counts per column. And if I just, also show you the value, right? So from class 1, you have 1,339 images have class 1 as the class label. Class 2, class 3, and all the way to the last class. Now, we can actually, maybe if you want to get some percentages, like the percentages of class labels in the entire data set, you can actually use a pie chart. You can actually grab the data set and grab the columns and grab the labels out of them. So this is, again, something, I'm just being fancy here, okay? This is just going through the data set, data frame, where in this case, this is df, data frame, go into the columns, convert them into a list, and grab anything that lives beyond index 2. So this is literally the name of the classes, right? So in order, I mean, if you want to be lazy, you can really hand code this, right? Because, I mean, if you look at df, you can literally go and create a list of names and sort of write them by hand. But why should we do that? We know how to work with Pandas. So I'm just going to go df.columns.toList and then 0, 1, 2. So from here, grab all the column names, right? So if you look at what you get, exactly the name of the columns. And I'm going to be using this to actually create a figure. I'm going to use Matplotlib to actually plot this, right? Matplotlib has actual .pie functionality to create a pie chart, which is very handy. So you grab this list of numbers, right? And then for the labels, you pass the column names. These are the labels that you'll see around your pie chart. And then this over here formats how you'd like to see the percentages. So this computes the percentages for you because you passed the number of each one of the class labels to it. Now, the double percentage sign actually puts the percentage sign next to the number, and this is literally saying up to 1 decimal point. That's it. And again, you can define a label, you can make sure that the axes are equal so that the aspect ratio is not all messed up. And that's it really. PLT axis equal and then PLT show. If you run this, looks very nice. We've got the title. For each class label, you have the percentage of percentage of images that actually have that particular class label set in their class label. Okay, there you go. Now we have gotten comfortable with this data set. In the next video, we will go over pre-processing these images, things like normalizing the pixel values, resizing the images, so that we can build up our way towards building a multi-label classifier and the subsequent videos in this series. Thank you very much.